Hi there, we're going to talk about doing a titration today, and we're going to determine the ionization constant for a weak acid. So we're going to find the Ka. So I'm going to put this information, this is background information that you can have to understand a little bit more about how we do titrations and what the different vocabulary is. This is just for you to read as background. I'm going to go through it with you now. So we're going to be using, we're going to be doing a titration. We're going to titrate a weak acid, which will be acetic acid, which is vinegar, and we're going to titrate it with a strong base called sodium hydroxide, NaOH. We are going to find how much sodium hydroxide will take to neutralize the acetic acid. We're going to put an indicator in there called bromocresol green. Let me double check that. Yeah, bromocresol green will be our weak acid that we're going to be looking at. It's going to help us, this indicator is going to help us figure out a Ka value, and that's called dissociation constant. We're going to be using that chemical, that molecule, which is a weak acid, to figure out the Ka for that weak acid. We also have vinegar in there, so we're going to be doing acid-base indicators can be weak acids as well. So we have two weak acids in there. We have the bromocresol green, which is the indicator. It changes color. We're going to use that fact to help us. And then we also have the acetic acid, which is a weak acid. But the bromocresol green is going to be changing color first and helping us figure out the Ka just for the bromocresol green. You're going to do a similar lab for yourself as well. Hopefully you'll be in the lab to do that depending on our situation in class. And you'll be doing the same process. So this will be a good introduction for you to how to do the vinegar titration lab. Okay. So we always have a titrant, and that's going to be sodium hydroxide. That's a strong base. We always have a something we're titrating to see its concentration. So in that case, when you do that lab, it will be acetic acid, which is vinegar, and you'll have an indicator in there. When you do the lab yourself, it will be phenolphthalein, which turns from colorless to a pink color, which is a really it's a really quick change. So it's really helpful when we're doing that lab. So we're going to be using some information about how all this works. When you do the lab, and when we do the lab together, we're going to see a graph like this. And so it's going to be on the x-axis showing us how many milliliters of sodium hydroxide we use. That's the titrant. We're going to have a pH meter in the solution to see how the pH is changing. In the beaker, we're already going to have the vinegar, the acetic acid. We're going to be using a different indicator, not methyl red or phenolphthalein this time. We're going to be using the bromocresol green. When we do the lab, we'll start off and we'll see the graph shown to us, and we'll be adding the sodium hydroxide to the beaker. We'll be looking at the pH with a pH meter. We will also have that indicator in there, and it's going to turn from yellow in this area to a green color in this area, and then to a blue color here. So I'm going to let the titration go all the way from here all the way up to here. It's going to take a while, but it's okay. We're not interested in the equivalence point. We're interested in the half equivalence point, which is down here. So let me show you that. That's going to help us figure out the Ka. And you can also do math to figure out exactly where this equivalence point happens when you're doing a titration, and it's very helpful to find the exact point where the neutralization happens. So this graph right here is showing you that change in slope, and when you have this inflection point, that's going to give you the neutralization point. We are caring about this half equivalence point in this lab. when pH at this part here is half of the equivalence point, it's called the half equivalence point, the pH is going to equal the pKa. In this lab, we're trying to find this Ka, so this is a really helpful point for us. And that's where in our lab, it's going to turn from yellow color in this area to green. We want to know that green point. That's going to be B for us. So you need to look at the volume change from the beginning to that point, and that's going to be our half equivalence point. And that's going to be that pH is what we need to use to do the math on page 67 of your handout that you're going to be filling in. So we care right here at this half equivalence point called B. And we're not using methyl red, we're using the bromocresol green for our indicator. And let me show you the math of this so you get the idea. Remember, we're going to have a weak acid, which is the bromocresol green. It's going to dissociate with a H plus that will react with the sodium hydroxide we're adding, and then we'll have this A minus, the rest of the molecule. So we'll have remember acids always give off an H plus, and then they have the rest of the molecule left over as A minus. Remember, A is just like a generic way of talking about the part of the acid that breaks into pieces. So remember, acids have this H always usually written in the front. You have an H plus that pops off when it dissociates in water, and then you have the A minus side of that. This is just a generic way of saying the rest of the molecule. We're going to be looking at Ka today. So we're going to know that Ka is the molarity of the H plus. Remember, brackets mean molarity. The molarity of the second part of the molecule that breaks into pieces when it dissociates all over the undissociated molecule, because weak acids are going to have a lot of this in the water, and a little bit of this and a little bit of that. So that means you're going to have two small numbers up top and a big number down there. So this Ka for weak acids is going to be a small number. For strong acids, it's going to be a big number. So that's the difference. We're going to know that when we're at the halfway equivalence point, that these guys are going to be equal to each other. This is going to be equal to that because we're at the half equivalence point. So this value here, the second part of the molecule over the undissociated acid, these are going to be equal to each other because we're at the halfway equivalence point. And that makes the math easy. That's why we do it. Because when you have the same value for this over that, it's going to equal 1, and the log of 1 is 0. So that's why we do this way. And this fancy formula here is called the Henderson-Hasselbalch equation, and it helps us figure out how to get the pKa. So remember, P just means we took a log of something. So we took a log of that Ka number, and at this point, this part of this equation goes away because this is the same as 0, and then pKa equals pH, and that helps us a lot. We use this a lot to figure out the Ka of acids. So let's try the lab together, and I will leave this information for you as a supplementary reading for you to understand a little bit more. You can go back through this slowly and understand this more thoroughly. So I'm going to close this out and minimize it, and then we're going to do the lab together. Alright, so we're going to have a titrant, and we're going to have the titrant be a strong base, which is sodium hydroxide. So we're going to fill up this. This is the burette. Let me talk about everything we've got here. We've got to have a burette. We have a pipette. We have a pipette bulb that helps us fill the pipette. And we have the two things we're going to measure against. We have the sodium hydroxide, which is the strong base, and we have the weak acid, which is acetic acid. And then we're also going to put this indicator in there, bromocresol green. We're going to use our pH meter here. This is the probe we're going to use, and this is the meter telling us what's happening, what the number is. We're going to graph all that like we showed you, like I just showed you. And we're going to see the display here. So what you need to do is you're going to be watching the color change from yellow to green. When you see that color change, you need to, at the beginning, you need to take this volume here as our starting volume is 0. And burettes are written upside down because we're going to take the final volume minus the initial volume. So it's nice if you start at 0. You don't have to, but we're going to start at 0 to make our lives easier. And we're going to see the difference in volume that we took to add to the beaker. Okay. So you need to write down the volume. Starts at 0, and then wherever that volume is, where it turns green, right when it turns green, you need to write that down. So it's a good thing we're on video. You can just go back and stop. As soon as it turns to that green color, you need to write down the final volume from the burette. And then the difference is the volume of the sodium hydroxide we use. So you can use that information to help you figure out the Ka on page 67. Okay, so let's fill everything up. Let's make sure, oh, this is already filled up because I got it all filled here. Sodium hydroxide is in the burette. And we're going to need to titrate this acetic acid. So we're going to need a beaker. We'll put a beaker here. We will fill a bunch of this acetic acid in here. So we have lots to test. Okay. We're going to need exactly 10 milliliters of this acetic acid. And the molarity of this is 0.1031 molar. So you'll need that information. And then the molarity of the titrant, sodium hydroxide, which is the strong base, is in this burette, is 0.1104 molar. So you're going to need that information to figure out when we do this lab, when you actually do this lab yourself, when we do the vinegar lab, you're going to have these numbers to do the vinegar lab. Right now we are lucky because we're just going to use that pH number to figure out the Ka, because remember I showed you we can make this a lot easier on ourselves if we find the pH number and use it to figure out the Ka. Alright, so here we go. We're going to grab this, we're going to fill this pipette because I want exactly 10 milliliters of the weak acid there. I'm going to put that over here. I don't need it anymore. I'm going to get a fresh beaker. I'm going to empty the pipette. I'm going to put it here underneath the burette. It's got a stir bar in there. The magnetic stirrer is stirring. It makes it really good to see the exact endpoint. So we always want to have a stir here and a stir bar. If you don't have those, you're going to manually swirl the beaker or the flask that you have under here. Okay, this is what people forget to do all the time. They forget to put the indicator in there, and then they go and the color never changes. So we always want to make sure we have an indicator in there. So we're going to put this is the weak acid we're going to test out. We're going to put some in there. You're going to start with yellow. Remember, you need to look for exactly the volume when this turns green. That's what we're looking for. Okay, so it's nice we're on video. You can go back and forth and make sure that you know we started at 0 for the titrant and then wherever we end up to get to the green color. Okay, I'm going to let it go all the way to the blue color so you see how the graph will look when we're titrating a weak acid. Okay, so I need to put my pH probe in there. I already calibrated it with pH 4 buffer and pH 10 buffer, so we know we're in good shape. So we're starting at 2.88. I'm going to graph this, which I said I'm graphing. Okay, so it will show up on the graph. And then we're going to start the burette going. So we're going to let this slowly, drip by drip, let this titrant go into the beaker. So remember, you're going to be trying to find out exactly what volume happens when we have a change from yellow to green. Okay, so that's what we're looking for. You are going to see later a change from green to blue, and that's going to be the equivalence point. But we're trying to find green, which is the half equivalence point. Okay, so I'm going to let this go in slowly, and I'm going to stop talking, and you're going to watch for green, and you're going to remember that we started at 0, and then wherever we end up, that's how much volume of sodium hydroxide we added. So I'm going to let this go slowly, and I'm going to stop talking so you can watch, and it'll take us a while because I'm going to let it go really slowly. So it's going to take us a little bit. There's your green, so make sure you wrote down the volume there. I'm going to let it go a little faster now so we can see the whole graph. Maybe go faster. I just have a little trouble with this burette on this program. Okay, maybe it's going to go slow. There we go, a little faster. So now you're going to see the change in the graph. We were at the half equivalence point for the green change, and now we're going to change to blue. It's going to take us a little bit. There's your blue, so you're going to see in a bit that equivalence point on the graph. So like I said, we care about the green because we're trying to figure out the Ka. But if you were doing, when you do the vinegar versus sodium hydroxide lab, you're going to want this, you're going to want the equivalence point, which is right here. You're going to want this when it's in the middle of this part. That's going to be your equivalence point. Okay? And you'd want to stop your titration right when it's changing from, when you do the lab, it'll be clear to colorless because we're using a different indicator. We're doing the same titration though. We're doing acetic acid, which is vinegar, versus strong base sodium hydroxide. So it's a strong base versus a weak acid. So when you do your lab on your own, you're going to be doing the same titration. The only thing different will be you're going to add, you're going to add not bromocresol green, but you're going to add the phenolphthalein, which will change. It'll be colorless in this area, and then it's going to turn a bright pink when you get to that equivalence point. Okay, so I'm going to stop. I'm going to save this. I'm going to stop this guy. Oh, stop. So when you do this in the lab, you have to get used to this. It's different because I'm on a computer, but you have to get used to this stop clock and how to go slow and fast. When you get really close to the equivalence point, you're going to want to go really, really slowly because you want the one drop that changes from colorless to pink. So that's really important because you want to, this change right here happens in one drop, and you want to get that exact volume for that change. Okay, so remember, in this lab you want to know the volume that we had on the burette at the green point, not where we're at now. You want to know the change from when it changed from yellow to green. You want to know that volume. So if you missed that, then go backwards in the video and get to the point where it turns from yellow to green and write that volume down. That's what we need to know when we're doing the halfway point. Okay, so this volume is important. So we're going to save that, save this, and here's the data. If you there's that graph, and so that will help you. And so you're going to fill out the paperwork that goes with this, and you're going to submit it to me in one PDF. And I hope you got a lot out of titration. It's a very important skill that we're going to use a lot in chemistry. All right, talk to you soon. Bye-bye.